Hello everyone, so our next mechanism adalah mechanism of Friedel-Craft acylation of benzene. Okay, so this one involve acyl group. Acyl group is C double bond O attached with alkyl group, and this one attached to halogen lah, sama ada Cl ke. So dia akan jadi acyl chloride. Okay, tapi kalau attached dengan Br, acyl bromide lah. Alright, so benzene when reacted with this acyl chloride in the presence of catalyst, it will form this ketone here, okay, and side product is HCl. Alright, so for this mechanism, dia nak macam sama mechanism yang lain juga. So the first step adalah formation of electrophile. Okay, so as you can see, we are going to substitute this C double bond OCH3 into this benzene ring. So kita kena bagi benda ni jadi electrophile dulu. Okay, so how to turn this structure here, acyl ni jadi electrophile, kita perlukan bantuan AlCl3. Okay, so in the previous video, I already mentioned that AlCl3 is a Lewis acid, electron deficient species. So they are the empty orbital that can occupy electron lah. So that's why the electron from this Cl actually boleh di donate ke Al. Okay, so we are going to draw the mechanism. First, I will show the electron on Cl and then draw, okay, arrow from Cl to Al. Okay, sebab Cl ni yang kaya elektron, Al kurang elektron, so ini nucleophile to electrophile lah. Okay, and then from the arrow, you should be able to guess that we will use this lone pair to form bond between Cl and Al. Okay, so our product will be CH3, C double bond O, Cl. Okay, tinggal dua lone pair and another lone pair is used to form bond with AlCl3. Okay, and over here we have to check the charge. Okay, so sini Cl. Alright, so charge dia Cl ada 1, 2, 3, 4, 5, 6 je electron around it. So 7 valence electron minus 6 is plus. So Cl charge positive while Al charge negative. So sama macam before this. So kita akan form this complex, but this complex can break here. Okay, dia lain daripada tadi. The bond here is weak lah. So we can break the bond. Okay, so arrow from tengah bond pergi ke Cl. Okay, so kita tahulah when this bond break, yang dapat elektron adalah yang more electronegative, which is Cl. Okay, carbon tak dapat elektron tu lah. Okay, so kita kena draw our product. So our product will be C double bond O, CH3. Okay, and this carbon charge positive sebab dia tak dapat elektron tadi. Okay, dia kurang elektron. And if you count the former charge pun ya, plus 1. Okay, and then next one, the side product yang penting juga untuk the first step ni adalah kita akan form AlCl4 minus, ataupun we can just write it like this, AlCl3, and then ada bond dia with this Cl here. So AlCl4 minus lah. Right, so this is the electrophile yang kita baru hasilkan tadi. Okay, so basically we use Lewis acid to form electrophile lah. Okay, so once kita dah ada electrophile, kan kita punya benzene adalah nucleophile. Okay, so kita boleh react dengan electrophile lah. Okay, right. Okay, so step 2, formation of Arrhenium ion. Okay, so kita ambil benzene reacted with this nucleophile. So arrow kita dari mana? Okay, arrow start from nucleophile, which is the benzene ring, to this carbon here. Okay, to electrophile. That means we will form a bond between benzene ring and C double bond O, CH3. Okay, so automatically this side here, carbon ni akan jadi partially positive sebab dia ada satu H and then dia ada 2 bond je. So total 3 bond. So kurang bond. So dia jadi charge positif. Okay. Alright. And this bond tak ada masalah sebab dia ada H dekat sini. Alright. Okay. And then next one adalah kita dah form dah our Arrhenium ion. We need to write resonance structure for this Arrhenium ion. Okay. Alright, so arrow kita kena go towards bond yang dekat dengan positif kan. So arrow dekat situ. That's mean over here pi bond break and then we will form double bond sini. So double bond, and then this double bond remain. Okay, so this one bonded to C double bond O, CH3 ni masih wujud, and then this carbon here will become positively charged. Okay, and then next one is this bond break and then form a new bond there. Okay, so kita akan form another resonance structure. Okay, and this carbocation sini. Okay, and then saya pesan dekat kamu kena letak square bracket. Okay, so and then we need to write down this is Arrhenium ion. Okay, so last step, step 3, deprotonation. That means we will remove H+. Okay, so H yang kita nak remove either H dekat carbon ni ataupun H dekat carbon ni. Tapi saya cakap H yang kita remove mesti H yang dekat dengan benda yang kita substitute tu lah. Okay, that means we are going to remove this H. Alright, so kita nak remove H ni by using this AlCl4- lah. Okay, and apart from that, reason kenapa kita kena guna ni sebab AlCl3 is a catalyst. That means we need to regenerate the catalyst lah at the end. So catalyst tu kita akan dapat balik. So that's why we need to use this AlCl4 so that AlCl3 can be formed. And then dapatlah catalyst kita yang asal. Okay, alright, so this bond antara Al and Cl we break. Okay, and then the Cl will get the electron. So Cl dah kaya electron, and then Cl2 will go and get this hydrogen here. While this bond between C and H bond will break, and then we will form the new bond by using that electron. Okay, so kita akan form double bond situ. Okay, so we can get back our benzene punya lah. Okay, so C double bond O, CH3. Okay, and our side product is HCl. And we get back our AlCl3. Okay, so done. So kita dah berjaya dapat produk yang exactly the same macam atas. So if you look carefully, step dia sama. Step 1 je totally different because we use the different reagent. Okay, and then step 2 sama juga, we need to show the Arrhenium ion punya resonance. Okay, and the last step we need to get back our AlCl3 sebab dia adalah catalyst, and then kita kena form balik pi bond yang ada dekat benzene. Okay, I will stop here. Thank you.